Welcome back, students. Good morning to one and all. Myself Sir Sunil, your physics teacher, and already we have started our second unit, physical quantities and measurement. And today we are going to discuss the topic vessels for measuring oleum. Okay, students, stay on video and watch the video carefully. All those who have the book, please take out the book. Okay, today's session we are going to start by the topic vessels for measuring oleum. In class 7, you have read that we use different vessels for measuring the oleum of liquids. Already we have discussed in class 7 about measuring cylinder and measuring beaker. And here we are going to discuss some more device. Okay, some more devices we are going to discuss here. Measuring cylinder we are going to discuss once again. Okay, students, it is measuring cylinder. It is made up of glass or plastic. Last year also we have discussed that measuring cylinder always made up of glass or a plastic, and is graduated in milliliter with 0 its mark at the bottom. Milliliter or ml with its 0 mark at the bottom. The graduations then increase. Upwards as shown in figure. Clear? You see the diagram already you have seen. First one, the standard measuring cylinder. Another one, pharmacist. They are using this type of measuring cylinder. You know that very well. Okay, two types of measuring cylinders are there. In 7th class we have discussed. Okay, both diagrams are very important. You have to practice. Okay, the graduations then increase upwards. The graduations we can see in the measuring cylinder. Okay, these are the graduations, and here these are the graduations. Okay, students, just observe it from bottom to top. The graduations increases. We have measuring cylinders available for different capacities. We have different types of measuring cylinders are available as different capacities: 50 ml, 100 ml, 200 ml, 500 ml, etc. The capacity of measuring cylinder is marked on it. Now we are going to discuss about measuring beaker. A measuring beaker is made up of glass. Measuring beaker also made up of glass, plastic or metal like aluminium. Also made up of plastic or a metal like aluminium. It is used to take out a fixed volume of liquids, say milk, oil, etc., such as 50 ml of milk or 50 ml of oil, like that we are taking. Okay, it is actually measuring beaker is used to take out the fixed volume of liquids for 50 ml, 100 ml, 200 ml, 500 ml, 1 liter, etc. Okay, to take out 50 ml or 100 ml milk from the large container and all, we are using the measuring beakers. The capacity of measuring beaker is marked on it. Different types of measuring beakers are there. Say first one, 100 ml one, 200 ml and 500 ml. Okay. Now we are going to discuss about Eureka can. About this Eureka can we have not discussed in 7th class. Okay, students. So take care. And Eureka can is a glass beaker with a side opening near its mouth, which it is known as spout. Eureka can includes a spout also. In sideways one spout is kept. Thus, the beaker can contain a volume of liquid up to the spout only. Clear? A beaker can contain a volume of liquid up to the spout. If you try to cover the water or liquid upside the spout, it's not possible. Any excess of liquid overflows through the spout. The Eureka cans diagram we can see here, the diagram we can see here, you just to observe it. This is Eureka can. This is Eureka can. The spout, I told you one spout is there, that is this is spout. Okay, you observe it. Now determination of density of an irregular solid. Determination of density of an irregular solid. To determine the density of an irregular solid, regular solid we have already discussed yesterday. By using the particular formulae we can find out the volume and density and all we can find out. But how to determine the density of an irregular solid? We have to measure its mass and volume first. Okay, mass and volume we have to find out. To find out the density, because density D is equal to m upon V. Okay, we know the equation. The mass of the body is measured with the help of a beam balance. Okay, very easy to find out the mass. If the beam balance is there, you can find out the mass of the body. But how to find out the volume? That we have to discuss here. To measure the volume of the solid, we use the displacement method. We use the displacement method. 7th class also, this one we have discussed. Please remember it. Okay. That is, a solid is when immersed in a liquid displaces volume of liquid equal to its own volume. When we immersed a solid substance in a liquid, some part of liquid will be splashed out. That will be the volume of the particular object or solid. The measurement of volume of an irregular body by displacement method can be understood by the following activities. Here we can have one activity. Okay, please go through it. First one, measure the mass of the given solid using a common beam balance. First of all, we have to find out the mass by using the common beam balance. Note the mass. Okay, note the mass and let it be m gram. Here we can take that one as m gram. Now take a measuring cylinder. Take a measuring cylinder. Fill it partly with the water. Fill it partly with the water. Already we filled here. First one you can see. Take measuring cylinder and fill this one with water partly. Okay. Now what we have to do? Note the level of the water. And later please note the level of the water. That will be taken as V1. That will be taken as V1. Now please immerse the stone in it. Please immerse the stone in it. Now tie the given solid with a thread and gently lower the solid, suppose stone maybe. Okay. Tie the given solid or stone with a thread and gently lower the lower the solid in water contained in the measuring cylinder. Now please immerse the stone or particular solid in the measuring cylinder contains water. What will happen? We know that the water level, that is V1. Okay. By keeping the stone in the measuring cylinder, what will happen? The water level increase, that will be changed. The V1 will be changed as V2. Now we know that the final level of the water and initial level of the water. Final level, that is V2, initial level, that is V1. Okay. So how can we find out volume? Volume can be find out by using this relation V2 minus V1. V2 minus V1 will give the volume of the particular solid. V2 minus V1 cm cube. Okay. Now first of all we have already find out the mass m by the beam balance. Okay. Now we got by the displacement method V volume. Now how can we find out the density? Density by using this relation mass upon volume. That means m upon V. M upon V. Okay. Suppose that the m is 78 gram. M is 78 gram and V is 10 centimeter cube. What will be the density? 78 upon 10 centimeter cube, that is equal to 7.8 gram per centimeter cube. Okay students, because 1 ml is equal to 1 centimeter cube. Now we will go to discuss activity 2. Take one Eureka can. Okay, already we have discussed about the Eureka can, maybe you are familiar now about the Eureka can. Place the Eureka can on the table with a measuring cylinder under its spout. Okay, pour water into the can until it starts overflowing through the spout. When the water has stopped dripping, remove the measuring cylinder, empty it, dry it, and again place it under the spout. Okay, now tie the given irregular solid. Okay, this will be the arrangement. First of all, what we are doing, we are pouring the water in a Eureka can till the level of the spout. Okay, and then also we are keeping, the first time also we are keeping the measuring cylinder near to the spout, and till the water splashes out you have to keep the measuring cylinder there, and later you have to remove the measuring cylinder and dry it. Okay, then again you keep the measuring cylinder under the spout. Okay students, now what we are going to do, we are going to immerse the stone, particular stone, in the water. When we immerse the stone in water, what will happen? The water level will rise, and that the particular water, that will be moved to the measuring cylinder. Okay students, now tie the given regular solid by a thread. Immerse the solid gently into the water contained in the Eureka can as shown in figure. We have explained the solid displaces water equal to its own volume. The solid displaces the water equal to its own volume, which overflows through the spout and it gets collected in the measuring cylinder. When water stops dripping out through the spout, note the volume of water collected in the measuring cylinder. The particular amount of water which is collected in the measuring cylinder, that will be the volume. Okay, suppose that the mass is 310 gram. The water collected in the measuring cylinder is 40 centimeter cube. Then what will be the density? Density D is equal to mass upon volume, means 310 upon 40, that will be given the answer 7.75 gram per centimeter cube. Now we are going to discuss about the determination of density of a liquid. The determination of a density of a solid we have discussed. First we found the mass by the beam balance, then volume we found out by first activity by the measuring cylinder directly, then next one by using the Eureka can. Okay, you understood now? Now we are going to discuss about determination of density of a liquid. To determine the density of a liquid, its mass m is measured by a common beam balance. Okay, by common beam balance we can find out the mass. Then density is calculated by using the relation D is equal to m upon V. Okay, activity is given here to determine the density of milk. Activity 3. Take a beaker, measure the mass of the empty beaker using a common beam balance. Let the mass be m1 gram. Okay, take a beaker, measure the mass of the empty beaker using a common beam balance. Let the mass be m1 gram. Then now take the measuring cylinder and pour the milk into it. A certain level, say 50 ml. 50 ml milk you have to pour in it. Take measuring cylinder. Okay, the measuring cylinder you have to pour 50 ml milk. That means volume V is equal to 50 ml. Volume V is equal to 50 ml. Okay students, 50 ml or 50 centimeter cube. Transfer the milk into empty beaker. Already empty beaker is there, okay. By using the common beam balance, we found that the m1 gram, the mass, we already find out. Now transfer the milk into the empty beaker, measuring its mass again, and mark that mass is as m2. Second one mass, that is m2 gram. Now find the difference between m2 and m1. This will give the final mass in gram. That is 51.5 gram. Okay, volume we already got, that is 50 centimeter cube. Okay, we already found out. And now what to do? Calculate the density of milk by using the formula mass upon volume, that is m upon v. Okay, here we know that the values m is equal to 51.5 by using the formula m2 minus m1. Okay, students, that is 50 centimeter cube is the volume. Final answer is 1.03 gram per centimeter cube. Okay, now we are going to discuss about the density bottle. Okay, this topic will be discussed tomorrow's class and tomorrow's section, and I hope that you understood today's portion. You read it 1 or 2 times. If you have any doubt, you can ask to me directly when class starts. Clear? So today, goodbye and have a nice day.